Hello everyone, my name is Amina Hassan, and for this presentation I would like to talk about the bridge pattern. So to start off, what is the intent of the bridge pattern? So the bridge pattern is basically a structural pattern design that allows you to separate the abstraction from the implementation. So in other words, it is basically when you are separating the construction of a complex object from its representation so that the same construction process can create different representations. Like, for example, if you have a complex representation and then you want to create one thing into several different targets or several different ways of showing that same one thing. So like, for example, if you had a large class or you had two classes that were very close to each other, then abstraction and implementation would be used, which can help you independently develop those two things together. Also, it allows abstraction and implementation to be developed independently, where you're basically going to take that larger class and then split it up into like two separate smaller classes, and you can make them abstract by making them abstract classes. You can also add one more method level redirection to achieve the objective. And the bridge pattern is mainly designed upfront to let abstraction and implementation vary independently. So the idea that abstraction and implementation can actually vary independently is what is very special about the bridge pattern, and that's the main thing that's very unique to it. Because in other patterns, you don't have that option where you can actually keep the abstraction of the entire class or the code or that you're working with. You can keep the abstraction and implementing separate from each other. Then let's talk about the motivation. So the motivation behind the bridge pattern is that it's mainly used when an abstraction needs different implementations. So for example, an object that handles the persistence of objects over different platforms. Which is usually used either in relational databases or file system structures. So two places where you can mainly use it is through database systems or file system structures. And then a good implementation would be to choose the extent of the object itself to actually implement the functionality for the system. An abstraction can also have like one of several, they can have like several possible different implementations. And the most common way that it's usually done through the bridge pattern is that we accommodate all these different implementations through the use of inheritance, where an abstract class defines the interface to the abstraction, and then there are concrete subclasses which allow you and help you to implement it in different ways. But this approach isn't always flexible, so that's why we use inheritance to bind an implementation to the abstraction permanently, which can also make it difficult to like modify, extend, or like even reuse those abstractions and implementations independently. So this is the UML class diagram for the bridge pattern. This is essentially like the backbone, the base UML class that we always have to look at when we want to like create any example for this pattern. So to start off, first we have the abstraction. So you have the abstraction class where the bridge pattern allows the abstraction and the implementation to be developed independently. And then we have a client code that can access only the abstraction part without being concerned about the implementation part. And then the abstraction is an interface or abstract class. And the implementer is also, so the implementer can also be an interface or an abstract class, either one, it's fine. And the abstraction here contains a reference. So it contains a reference to the implementer. And so children of the abstraction are actually referred to as refined abstractions. And the child of the implementer, those are known as concrete implementers. So you can see that there's also a concrete implementer here. And the children of the implementer are, that's basically what they are called. And since we can change the reference to the implementer in the abstraction, we are able to change the abstraction's implementer at runtime. So it can also be changed then. And changes to the implementer, however, so here, if anything, any change was to happen in the implementer code, then that wouldn't affect the client's code. Okay, so now let's look more closely at each participant in the UML diagram. So let's see exactly what are each of these elements, what are these participants that are here in the class diagram. So first we have abstraction. Abstraction is the class which contains the core of the bridge pattern, and it basically defines the crux. Also, it contains a reference to the implementer. So if there is an abstraction, you're not going to have that bridge pattern at all. Like that's why it's really just the core of this entire pattern. Then next we have the implementer, and the implementer defines the interface for the implementation classes. And it's not necessary for this interface to directly correspond to the abstract interface. It can be different. So it don't exactly have to be like have any connection with the abstract interface. And then there's also refined abstraction, where this extends the abstraction and it takes finer details one level below, and it also hides finer elements from any implementers. So over here we can see there's the refined abstraction, where it'll just take in like any other functions and any finer details, and it doesn't need to exactly be connected to like directly have a connection with the implementer. Whereas over here, the implementer, we can see it has a child class where for the concrete, that is the concrete implementer. And the implementer is also, it also generalizes with abstraction. And then we have the concrete implementation class. The concrete implementation basically implements the implementer by using a concrete implementation. So we can see that over here in the class diagram. So now let's look at a sample problem. So a sample problem that is using the bridge pattern. So here, for example, we have a vehicle, and the vehicle basically has, so this is like a manufacturing company, and they basically build two different types of vehicles. So the first type of vehicle they build is a bus, and then the second one is a bike. And so the bus has basically, you have to produce the bus, and then you can also assemble the bus, and the same thing is gonna happen with the bike, where you need to assemble the bike and then produce the bike. So this is a sample like example of how can we use the bridge pattern to fix this problem and make this much better than what it looks like right now. So a sample solution here. So using the bridge pattern, one way that we can solve this problem is that if you want to change the bus class, then you may end up changing like produce and assemble as well. So a better option would be that you basically solve the problem by decoupling the vehicle and the workshop interfaces. So you we're creating vehicle class and then a workshop class by separating those two. So those are the two main actions that are being done by the company or the manufacturers. And so the vehicles that they're building, producing, and assembling is going to be like bus and bike. And then the workshop is going to do the producing and assembling. So it's like a much cleaner, better way of implementing this problem. So some advantages of the bridge pattern are that the bridge pattern decouples an abstraction from its implementation so that the two can vary independently. And it's also used for implementing platform independence, and a runtime binding can be used as well for implementation. So you can, so using the bridge pattern, like a few things you can do is like you can create platform independent classes and apps, and then you can have like client code that works with high level abstractions, and then it's not exposing those platform details that maybe we don't want. And then it's also an open closed principle where, like, for example, you can introduce new abstractions and new implementations that are going to be totally independent from each other, which is the great thing about the bridge pattern. And it also has follows a single responsibility principle where you can just focus on high level logic in the abstraction and also focus on platform details in the implementation. So that definitely makes this as a really like easy to use pattern. A few disadvantages of the bridge pattern are that if sometimes so we have like there's obviously many different types of examples, and there's many different situations and problems you can have that you may want to solve. So if the code gets very complex, then applying it can get like the code can get very complex if the pattern is applied to like a very highly cohesive class. So that could be a disadvantage of the bridge pattern. Okay, so now let's look at how the bridge pattern is implemented. What is the implementation? What are the steps to following the bridge pattern and making a class diagram or writing out code for it? So the first step is that you have to identify the orthogonal dimensions of the class. So you need to know that what are you going to put as the abstraction, the domain, front end, back end, and then what's going to be your interface or implementation. And all of those things must be identified and defined right up front when you're looking at the problem. And then the second thing you want to do is you want to see what operations the client needs and define them in the base of the abstraction class. So whatever the client needs, define those in the abstraction class. And the third step is that we want to determine the operations available on platforms, so you know the ones that need abstraction in the implementation interface, so that you definitely know where you're putting that. And then the fourth step is that you should create concrete classes in your domain, but you must make sure that all of those any concrete implementation classes that are created in your domain follow the implementation interface. So they must follow the implementation interface. And then the fifth step is that you should add a reference field in the abstraction class for the implementation type. So this is like, for example, so basically the abstraction is going to take in most of the work to implement the object that was referenced. And then the sixth step is that you want to create refined abstractions for each variant by extending the base abstraction class. And then finally, the last step is that the client code should pass an implementation object to the abstractions constructor to associate one with the other. And then after that is done, then the client can forget about implementation, and then they can only work with the abstraction object. So once again, the bridge pattern is allowing us to do that implementation and abstraction independently. So next, I've come up with an example of my own using the bridge pattern. So this is the UML class diagram for it. So I basically have an abstract class here that is for like a swing. So this is basically an example that is taking, so this is like a manufacturing company is creating, they have a creator shop and they are basically creating two different types of swings. So first off, I have a a abstract class called swing that has a protected attribute of one store, and then the second store, which is returning creator shop. And then I also have two methods in here. One method is a public method, create, with a which is an integer, returns an integer, and then we have a protected swing method that returns an integer as well. And then the abstract swing class has two types of swing. So there's basically the kid swing, and this has the method create as well as the kid swing. And there's the toddler swing, which has methods of create and toddler swings, and these don't have any return type. Next, I have a interface called creator shop, which has a method called final results in it that's going to print out the final or calculate the final result of like whether so at the end of the program, it's basically the swing problem is basically going to tell whether the problem was solved and were these swings created and made. So I also have a put parts together class that's going to basically make sure that all the parts have been put together, and that is it's associated with the creator shop. And then there's the create class that is associated with the interface as well. And then the abstraction and the interface are obviously going to be associated with each other. So this is the code that I use. So I coded this example in Java. And this is basically demonstrates an example of the creation and assembling of two swing types. So here is the swing abstract class, the toddler swing class, the kid swing class, the interface, putting all the parts together class, the create class, and then the main that's going to put everything together and print or output. And then these are some references for the presentation. So now I'd like to go into a little more detail about the code. So, okay, so I'm going to share my code now on Eclipse. Okay, so now we're on Eclipse, and this is the swing example that I created. So basically here you can see there are 7 classes here. The first class is called swing.java. So this is the abstract class. The abstract class swing.java has it has one method, 2 methods in here. One is called swing, and then one is called create, and it is basically referencing and these 2 variables here. from the creator shop. So it's taking these methods from the creator, it's calling from the creator shop class. So next we have the interface, where the interface creator shop class, which has one method in it called final result. And then this is the put parts together, which implements the creator shop. And it's basically going to print our final result that's going to say whether the swing, so for the toddler swing or the kid swing, all the parts have been put together. And then this is the create class that implements creator shop as well, which so it's basically implementing the interface. And it's also going to print out a final result saying whether the swings have been created. Then we have, there are two, there are two refined abstraction classes that basically need to be there if you're using the bridge pattern. So this is the first refined abstraction class. And here it's called class toddler swing. It extends the class swing. There is two methods in here. One method that is super. It's basically public toddler swing, and it has two arguments in here that are the store and both types of stores, and then it's going to return those two types. And then there's also a create method in here that's going to print out the final result. Then there's a second class in here that is a refined abstraction. The second refined abstraction class for the bridge pattern that is used here because this is a second type of swing. So this is the kid swing, and then we also have two methods in here. And then lastly is the main.java. So this main class is going to basically call the toddler swing method and the kid swing method, and it's going to print out our final result telling us whether these two products have been created and all the parts have been put together. So I'm just going to run that. And this is the output we're getting that, so it is correct, and it is telling us that the toddler swing has been created and all the parts have been put together, and the kid swing has also been created and all the parts have been put together. And these are some references I used for this presentation to talk about the bridge pattern. And that's all I have for this presentation. Thank you so much for listening.